Hello, what is the resultant of the displacements 2 meters east, 3 meters north, and 6 meters west? Now I've covered vectors, things like adding vectors and a definition of equivalent vectors and other associated subtopics of vectors in my previous videos. But this one I'll recap some of the things as I go along. So first, we have the displacement 2 meters east, and we'll label this beginning with A. So we have A as our first point, and we have 2 meters going east. Let's make this a little shorter and a little further down here. So this is A. We have 2 meters displacement vector, and we have 2 meters going east, and that goes to B. And then we have 3 meters going north. Remember, we have north, we have east, west, and south. So going north, we have, to C, we have 3 meters. And then 6 meters going west, which takes us somewhere along here. And we have 6 meters. Now the resultant of this is this line here, arrows going in the opposite direction to these. So these are going in this direction. The resultant is the arrow going in the opposite direction that connects A to D. Now we can draw some broken lines along here, and we can see that we can complete a rectangle. Now, if we look at the displacement AB, so this is the notation for displacement from A to B, which is what we have in the diagram. Then if we add this displacement to BC, and we add that to CD, we'll have our resultant, which is AD. So these go in anti-clockwise, and AD is going in the clockwise direction, which is the resultant of AB add BC add CD. Now angle AED, if we look in angle AED, AED, we have that AD squared. So I forgot to put E here. So we're talking about this AED. AD squared is equal to AE squared add ED squared. Pythagoras' theorem for this angle theta. So if this is 6 and this is 2, then this is actually 4. And we have that this height is also, or this distance is also 3. So if we look at AE squared, which is 4 squared added to 3 squared, gives us 16 add 9, and AD squared is equal to 25, so AD is equal to 5. Now if we look at theta, and if we want to find the angle theta, we have that tan theta opposite side, which is 4/3. So that's the angle tan theta. So if you want to find theta, we just have to find tan inverse of theta, which is tan inverse of 4/3, to find theta. So we can conclude hence that the resultant is 5 meters in the direction we have. It's going northeast, so we have in the direction north the angle tan inverse 4/3 is going northwest. That's the resultant, going northwest. So it's north tan inverse 4/3 west. And that's it. That's the resultant of the displacements: 2 meters going east, 3 meters going north, and 6 meters going west. So the concepts here are just plain to add in vectors here and determine the resultant vector. And further to that, the angle in which it makes with the line going north. Thanks for watching. I'm Alistair.